All right, lesson 41, unit 7-5, page 456 is solving trigonometric equations. Now, what it says, this is the worksheet, it wants you to solve for the principal values of x. An x that would make that true. So we're looking for a value of x that would make that left side equal to 0 on the right side. You might could do a little bit of graphical approach and try to do that, but that's not really what we're going to do. We're actually going to solve on paper. And remember, when you solve, we're going to solve in the order, please excuse my dear Aunt Sally. We're going to do anything we can in the order, please excuse my dear Aunt Sally, to simplify. Get the variable we're isolating on one side of the equal sign, remembering to change the sign when we cross over. And then we would undo in the reverse order of operations. Sally, Aunt dear, my excuse, please. What we want to get it down to is sine of x is equal to a number, and then hopefully x pops into our brain. What angle has that fractional value? It could be in the solving process that we would want to substitute an identity in to make our solving more palatable. Okay? And we could run into all kinds of stuff. Anything up through college algebra is fair game on this. So our solving could be as simple as algebra 1 equations to solve. They could be more complex, as in quadratic equations to solve. And then they could be even more complex than that. So we'll just have to see what happens to us as we go per particular problem. Okay? So what we want to do, basically, is we want to get sine x all by itself. We want to get sine x is equal to some number, and then we could say the sine of what is that number. Well, the junk on sine x that we don't want on sine x is multiplication and subtraction. We're going to be undoing, and you undo in the reverse order of operations. Sally, Aunt dear, my excuse, please. So we would begin by undoing subtraction by addition. So we would add 1 to both sides. And so we would have square root 2 sine x is equal to 1. We're isolating sine x. Now we need to undo multiplication by division, so we'll divide both sides by square root 2, and we're going to have sine x is equal to 1 over square root 2. But we can't leave a radical in the denominator, so we're going to rationalize. So we rationalize by multiplying the numerator and denominator by the radical denominator, and we get square root 2 over 2. And so we're thinking the sine of what is square root 2 over 2, and we know that that is 45 degrees in terms of degrees. So the principal value of x that would make that true is 45 degrees. Now, we would know this also. We would also know that if sine is positive in quadrant 1, it's also positive in quadrant 2, and 135 degrees in quadrant 2 has a reference of 45, and it's also positive in quadrant 2. So x would be 135 also is another option. If we think about the primary function, or the principal function, the principal value would be 45, although 135 is also a value that would make it true. And obviously, we could go around and around and around and around and get an infinite number of values if we went around the circle. So we're going to say that 45 degrees is the principal value of x that would make that true. Any questions on number 1? Okay. Number 2. Number 2, we have cosine square x equal cosine x. Cosine square x equal cosine x. Now, what we want is sine, cosine, tangent, secant, cosecant, or cotangent, x equal a number. And then we'll think through our head in our unit circle stuff and figure out what that is. Well, we've got a square. And if you have a square, that means you have a quadratic if you're talking about an equation. You've got a square on one side and an x on the other side. which means you have two names. Remember Algebra 1? X is a name, X squared is a different name. You cannot use the order of operations if you have more than one name. So you can't use the please excuse my adherent Sally thing here. It's a quadratic, and what do we do with quadratics? Set them equal to 0. So we're going to have to set our quadratic equal to 0. So we're going to subtract cosine x from both sides. And then we will have cosine square x minus cosine x equals 0. So we set it equal to 0. Now, way back in my Algebra 1 book I wrote on page 215A, AA, AAA, it begins to talk about what do you do if there's an A and a C? What do you do if there's a B and a C? What do you do if there's an A and a B? Okay? There's not a C, so we're not going to use the AC method. There's an A and a B, right? We have 1 cosine square x minus 1 cosine x. We've got a square term and an x term. That means we've got an A and a B. When that's the situation, what you're going to do is just factor out. Now, this is not AC factoring out. This is saying, what do these two terms have in common that I can factor out? This is regular distributive property backwards. What can I pull out of a cosine square x and a cosine x? A cosine x. So I'm going to factor out a cosine x, and then we think cosine x times what is cosine square x? Well, cosine x. And then we think cosine x times what is negative cosine x? Negative 1. So now I have cosine x times, parenthesis, cosine x minus 1 equal to 0. Now what did we do in Algebra 1 to go from there? We set each factor equal to 0 and solve. Remember that we're going to have two principal answers if there's a quadratic, right? Two principal answers. And so we're going to say we're going to let the first factor, cosine x, be equal to 0, or we're going to let the second factor, cosine x minus 1, equal 0, and we'll solve each one. So because it's a quadratic, there's two principal answers rather than one principal answer as we learned way back there in algebra. So we're going to say the cosine of what is 0? 90 degrees. Based on our memory of unit circle information. Now, that's going to happen again at 270, right? But our principal one, our first one that appears, is 90. And then when we go to this one, we have to get a number, so we need to get the cosine x all by itself. So we're going to undo subtraction by addition. So we're going to add 1 to both sides to isolate the cosine x. So now we're saying cosine of what is 1? The cosine of what is 1? 0. So x is equal to 0 degrees, x equal 90 degrees are the two principal values of x that would make that quadratic true. Any questions on number 2? So we're really just using all of the algebraic solving methods we learned before. It just has some cosine stuff attached to it. Any questions so far? Okay. Let's look at number 3. Number 3 says find the values of x between 0 and 360. Now we're going to find all those other ones that we kind of said, well, there's another one like 135 on number 1, but we want the principal one. Here we're going to find all of them all the way to 360. And so we're going to have square root 2 cosine x plus 1 equals 0. Remember, we're going to isolate the sine x, cosine x, tangent x thing. We want the junk off of it. We're going to have multiplication and addition. Let's talk about what we talked about in Algebra 1 again. How many names do we have? we have one name, x, and it's to the first power. That means there's only one principal answer, except for in the unit circle, it can appear again and again and again. Okay? So we can solve using the order of operations because there's only one name. We're going to undo addition first by subtraction. And so we'll have square root 2 cosine x equal negative 1. We need to undo multiplication by division, so we divide square root 2. We get cosine x is equal to negative 1 over square root 2. Understand so far? You cannot have a radical in the denominator, so you're going to rationalize. And so we have cosine x is equal to negative square root 2 over 2. Understand how to rationalize? So we got to think the cosine of what is square root 2 over 2, and where does it happen that that's negative? Okay? Now, first of all, the cosine of what is square root 2 over 2? 45. But a smart trig class, where is cosine negative? Quadrants 2 and 3. Cosine is positive in quadrant 1 and 4. So we need the reference angle for 45 in quadrant 2 and in quadrant 3, right? So the reference angle for 45 here, excuse me, is 45 before 180. If I did 180 minus 45, I would get 135. And then it would be 45 after 180. So it would be 180 plus 45, which is 225. If you can see those. And so x is equal to 135 degrees. And x is equal to 225 degrees. It wanted us to find the values of x that would make that true between 0 and 360 degrees. Let's see how we found that. Okay? So we solved it. We thought about the angle. We thought about where does that happen, that's negative. It happened in quadrant 3. What are the reference angles? What are the angles that would have a reference of 45 that lie in quadrant 2 and 3? And we found those to be 135 and 225. Okay? Any questions there? Good? Okay. Number 4, sine 2x is equal to negative sine x. Now, there's a little situation here. We have a double angle identity, and we don't have a way of getting that off of there with some undoing stuff. The only way we can deal with that is to replace it with the double angle identity rule. So we're going to need to make a double angle identity substitution here before we start any solving. Sine 2x is equal to what? 2 sine x cosine x. Now that 2's not on there, and that's equal to negative sine x. So we got rid of that double angle situation with our double angle identity, which is on your sheet that you can either look at or memorize. We need to know enough about it to know that there exists something to replace sine 2x with, right? And then you can look it up if you have to. Now, we want to get sine x cosine x by itself, set it equal to a number, and so what we could do is we can set it equal to 0, or we can just get this off to get it on the other side. So I'm going to move this over here with the rest of the stuff just to have a number 0. And so I'm going to add sine x to both sides. Now I could have divided by it, right? I'll show you that in a minute. I could have divided both sides by that and got a 1 over there instead of a 0. There's no rule that says I have to make this a 0, because it's not a quadratic. So let's kind of look at this maybe two ways. If I did this, then I would have 2 sine x cosine x plus sine x is equal to 0, right? And then I could say, well, I see a common factor of sine x that I can factor off. So I'm going to pull off that common factor sine x. And I would have sine x times what is 2 sine x cosine x? Well, 2 cosine x. And then sine x times what is sine x? 1. So I have sine x times 2 cosine x plus 1 equals 0. And then I would say either the first factor, sine x equals 0, or the second factor, 2 cosine x plus 1 equals 0. I have two things that multiply with an answer of 0, so one or the other of those two must be 0. So we're going to say, well, the sine of what is 0? 0. And if I'm between 0 and 360, then where does it happen again? Because it didn't ask for the principal one, it asked for all of them between 0 and 360 degrees, right? Very good. And then I'm going to solve here. I'm going to get the junk off of cosine x. I have multiplication and addition. I'm going to undo addition first by subtraction. And then I'm going to have 2 cosine x equal negative 1. Undo multiplication by division. And I'm going to have cosine x is equal to negative 1. And I'm going to say the cosine of what is negative 1? Well, the cosine of what is 1? 0. But negative 1, 180. I got an identical answer. That's okay. Oh, it's negative 1/2. I lost my 2. There we go. Sorry about that. That's negative 1/2. Okay. Sorry. The cosine of what is a half? 60. Cosine of what's a half? 60. A, smart, trig, class. We want to be negative, so we need to be in quadrants 2 and 3. We want 60 less than 180 and 60 more than 180. And so x here would be 120 degrees, or x would be equal to 240 degrees. So there's 4 answers. X equals 0, x equal 180, x equal 120, x equal 240. That's a 40, not a 46. But still, we got that. Now, let me talk about one thing here. Let me just kind of show you something. What if I said I'm just going to divide this by negative sine x? That's going to become a 1, and that's going to cancel, and I'm going to have negative 2 cosine x. And all of a sudden, I've got something kind of like that. Because when I divide by 2, I'm going to get cosine x equal. And if I did that, I would get this. and I kind of lost the other part of my answer. You see how that happened if I went that direction? Because I just wiped out the whole sign situation. So it was better for me not to let my sign go. Now, also we would have to think division by 0 is mathematically undefined. So if I had the sign of some number that came out to be 0, then I would have to leave that number out of the domain, right? So that would exclude some things from my domain. But it's interesting that we could actually divide both sides by sign, and we would still get part of our answer, but we lost the 0 and the 180 portion of our answer. Kind of interesting there. The question is, would that be right or wrong? It's actually wrong because you lost half of your answer. And so you realize when there's sine and cosine involved, you need to solve so that you get a picture of both of those ideas going on instead of trying to wipe one totally out. When you wipe something out sometimes by factoring, then you lose some of your visual. I'm not real sure exactly how I need to try to explain that. There's some possible solutions there that kind of disappeared as we tried to solve it that way. Sometimes in calculus, when we over-reduce, we don't get pictures of things we need to get pictures of. And it's still, the equation that we have is equivalent to what we started with, but it doesn't reveal all that it needs to reveal. Well, I would go back and say this has a sine x something, and this has a cosine x something. And I really need to find out what sine x is. I need to find some sine x answers, and I need to find some cosine x answers. And so if I solve and I wipe out my sine x, I'm going to miss something. You just kind of get to knowing that. Yeah, you're going to, see, this double angle identity produced a sine situation and a cosine situation, and we're thinking at the end we need to get some kind of visual of what would be happening in both of those spots. Yes. So basically this factoring scenario got rid of something visually, but it was still a part of the original problem, and we need to know what was happening had we not factored that out. Yeah, I don't know how else to say it besides that. That's kind of all I can say, I think. All right. Oops. Any questions so far? All right. Now, number 5 says solve for angles between 0 and 2 pi. That's what we just did, right? We just said 0 to 360, but there's not any difference. But we might want to write these in terms of pi. So number 5, we have 4 sine square x plus 1 is equal to negative 4 sine x. Okay. Wow. Now we have a square to the first power and a constant. We have an a, b, and c. That means we're going to have to solve using the AC method more than likely, right? And we're going to have 2 primary solutions because it's a quadratic, plus all the scenarios of quadrants and all of that. All right, so let's deal with this. This is a quadratic because we have a square, a first power, and a constant. To solve a quadratic, you must first set it equal to 0. So we're going to move this to the other side so as to set the quadratic equal to 0. And so we have 4 sine square x plus 4 sine x plus 1 equals 0. I'm going to let everybody take a look at that, and then we got to talk about a little trick that we learned in college algebra, or the first half of pre-cal, as this course would be. You actually learned it in Algebra 2 also. We're saying this is a quadratic because I have this thing right here to the first power, and I have that same thing squared. Now the thing that I have to the first power and the thing that I have squared is a sine x. And sometimes it gets ugly to look at it like that in a quadratic. So what you learned to do back there in algebra was let that thing be u. We're going to let u be sine x, that thing that we had to the first power and that thing that we had to the second power. And we're going to rewrite this in terms of u, and we would have 4u squared plus 4u plus 1 is equal to 0, and it's just a little bit more palatable. Now, we can solve using the AC method of factoring, or we can solve with the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. This one's not so bad with factoring, right? 1 times 4 is 4, and what can you multiply to get 4 and add to get 4? 2 and 2, so anyway, so let's take a look at that. So we're going to say, okay, I want to take my a value times my c value. My a value is 4, my c value is 1. 1 times 4 is 4. Now everybody needs to know how to do the AC method. If you don't remember the AC method, you're probably not the only one, but you still need to remember the AC method, okay? And then what I did in Algebra 1 class on page 213 of my algebra book is I said, okay, the answer was positive, and so we're going to think when you multiply with blank signs, the answer is positive. When you multiply with same sign, answer is positive. So step 1, multiply a times c, think about signs. Step 2, find all the factors of your AC answer. The factors of 4 are 1 times 4 and 2 times 2. And we know that to multiply with the same sign, the answer is positive, so these need to be same sign factors. Step 3, pick the pair that add to give you the b value of 4 using sign rules. The sign of the b is positive, so now we're going to say our sign rules. When you add or subtract with the same sign u, add and take the common sign, which needs to be positive, so they need to be the same sign and positive. 2 and 2 make 4. We picked the pair that had to give us b, 2 and 2. Next step, split the middle term into those two pieces. So we're going to rewrite 4u as 2u plus 2u. We split the middle term into those two pieces, 2u and 2u. This is very important review we're doing here on this lesson 41. So hopefully you're soaking these things in. We're going to bring back down the 4u squared. We're going to bring back down the plus 1. So we multiplied a times c. We found all the factors of AC. We picked the pair that had to give us b using sign rules. We split the middle term into those two pieces. Now we factor the left pair and factor the right pair. What can you factor out of 4u squared and 2u? 2u. So we say 2u times what is 4u squared? 2u. And 2u times what is 2u? 1. What can we factor out of the right pair? Now we have to factor something out. A 1. You have to have a number there. You got to pull a 1 out. That's all you can pull out. So you can have 1 times 2u plus 1. And you know that we were hoping for, in the AC method of factoring, a common binomial. Because if we didn't get that, we couldn't factor. We'd have to go to the quadratic formula. So now we're going to write it as the product of two binomials, 2u plus 1 times 2u plus 1 equal 0. Now, if you had recognized this as a binomial square way back yonder, you could have done that in your head. I wanted to teach you the AC method, so I went ahead and went through that. So now we can say either this factor 2u plus 1 equals 0, or the other factor 2u plus 1 equals 0, which is obviously going to give us the same result. And for those of you who remember all of your algebra, you know that that means that there's a quadratic that's setting on the x-axis, and we have identical twin roots, right? One real root. Okay, anyway. And so we've got multiplication and addition, and we would undo addition by subtraction. I've got to put it somewhere. I'll come over here. We're going to have 2u equal negative 1 divided by 2. And we get u equal negative 1/2. And that's what we would get on the other one. Now, all we did was found u, which we let be equal to something a while ago. Okay? Is everybody good there? Let everybody catch up. Make sure we can focus on u. Aren't you glad? We've been focusing on pre-cal all year. Now we can focus on u. We said in Algebra 1, the y would say, I want to talk about me. Remember that? I want to talk about I? Anyway. So we got u is negative 1/2. We're going to need to put it right there, right? We let u equal sine x. We actually let sine x equal u. And u is equal to negative 1/2, which means that sine x is equal to negative 1/2. So now we have sine x equals something. Now, it could have been two somethings. These were just identicals, right? So we could have had to done that twice. Sine x equal this one, sine x equal that one. Okay, the sine of what is 1/2? 30 degrees. But we're talking about a negative, and sine is negative in quadrants 3 and 4. So we need to be 30 degrees over 180, which would be 80 plus 130, which is 210. And then we need to be 30 less than 360, which is 330 degrees. And so it's going to be at 210 degrees and 330 degrees. Any questions there? Oh, and we wanted the set of all. Yes. Do what? Radians. Radians. Thank you. In terms of radians, that would be pi over 6, correct? And this right here is pi, which would be 6 pi over 6. So that would be one more, which would be 7 pi over 6. And this is 12 pi over 6, right? Because it's 2 pi. So it would be 1/6 less than that, which would be 11 pi over 6. So in radians, it's 7 pi over 6 and 11 pi over 6. 1/6 more than pi and 1/6 less than 2 pi. There we go. Thank you. You knew that. Yeah. Let my mind slip a bit. All right. Any questions there? Wow, that was a big thing to bring back in. Let sine x be u, do the AC method, plug it all back in. Did I lose anybody? Is everybody okay? Good? We really ought to have a test on this, you know. I know the year's about out, but this would be a fun one. We just don't have a lot of time. I don't want to, at this point, I want you to be able to focus on rehabbing some tests instead of trying to stick another one in and figure out how to deal with it. But anyway, this is good stuff, obviously. Let's go ahead and look at number 6. Yes, ma'am. Okay. Number 6, we have sine x is equal to cosine 2x minus 1. What's the first thing you see that we're like, don't like that? Cosine 2x. We need sine x, cosine x, tangent x. We don't need the 2's and the halves and all that stuff. So we're going to use our double angle identity to change that into, I think it's 1 minus sine square. Is that right? 1 minus 2 sine square. Got to, yes. Because we've got a sign here. So we're going to have 1 minus 2 sine square x minus 1. We just replaced the cosine 2x with 1 minus sine square x. That part was an identity. And then we still had the minus 1 at the end. And so we have sine x equal. Now, once we made the identity change, the cosine's out, so we're not going to worry about trying to relocate a cosine. After the identity substitution, everything is sine stuff, so we're going to focus on sine square. Now, we do, though, have a sine square, and we do have a sine to the first power, and so we're thinking quadratic, and we're thinking, this may be another AC method, but the 1's cancel out. And so we have sine x equal negative 2 sine square x. We don't want to divide by sine x. We could, but that makes it messy. We need to really solve it as a quadratic, right? And so we're dealing with the quadratic, so we're going to set it equal to 0. So we're going to move this term over to the other side, remembering to change the sign when you cross over, as we said on page 33 of our Algebra 1 book. And so we have 2 sine square x plus sine x equals 0. We see a factoring opportunity. There's not a C, so we're not going to use the AC method. We see a common sine x factor, and so we're going to pull out that common sine x factor. So we say sine x times what is 2 sine square x? Need the 2 and another sine x. It's allergy season, right? Need some sine x. Anyway. So sine x times what is going to give us sine x? 1. I just want to say that once before I finish these videos. Anyway, so we have sine x times 2 sine x plus 1 is equal to 0. We've got 2 factors equal to 0, so we're going to set each factor equal to 0 and solve. So either the first factor of sine x is equal to 0, or the second factor of 2 sine x plus 1 is equal to 0. And so we're going to say the sine of what is 0? The sine, and we're dealing with 0 to 2 pi, right? So the sine of 0 is 0. But if you went all the way across the other side, right, the other quadrantal angle across from it, it would be the negative of that, negative 0, which is still 0. So that would be at pi in terms of pi, radians. And then we're going to solve the other one. We have multiplication and addition. We're going to undo addition by subtraction. Subtract 1. We will have 2 sine x equal negative 1. Undo multiplication by division. We will have sine x equal negative 1/2. Sine is negative in quadrants 3 and 4. We're going to say the sine of what is 1/2? Pi over 6, 30, which is pi over 6. But it's negative in quadrants 3 and 4, excuse me. So we need to be 1/6 past 6 pi over 6, correct? Which will be 7 pi over 6. Or we need to be 1/6 less than 12 pi over 6, which is 11 pi over 6. So x equal 0, x equal pi, x equal 7 pi over 6, and x equal 11 pi over 6. 4 values of pi between 0 and 2 pi that would satisfy that equation. Any questions on number 6? Okay. Well, we'll stop there and we'll get the rest to it the other two in another recording. Good stuff. That brings a lot of algebra into the trigonometry that we're trying to do.